this is just equal to negative tangent squared x. Okay? So there's multiple ways to solve it. This is the easiest of the two ways. All right. Today we're going to verify some identities. This one has some spelling mistakes on it. Hopefully yours does not have spelling mistakes on it. Apparently my spell check wasn't checking the spelling until I read through it. All right. We already did the first two. The first two is choose one side and then simplify it as best as possible. So this is kind of like our checklist. Don't go to number 7 and do that one first. Choose a side. See if you can reduce it. One trick is to write everything in sine and cosine if you can. Number 4 is multiply the numerator and denominator by one of the expressions of the numerator and denominator of the other. And we'll get to that. We can also create, if I just have one fraction, I can push it into 2 separate fractions. So I could rewrite this, seeing that this isn't even simplifiable. I could rewrite it as sine of x over sine of x plus cosine of x over sine of x. And a lot of times that's going to be a lot easier to simplify. Likewise, in 6 is combine stuff. If you have fractions, combine them into one whole big fraction. The last one is work on both sides independently. All right, note the thing that says independently. Independently. That means there is no cross multiplication. There is no squaring both sides. There's no taking the square root of both sides. There's no multiplying by 2 on both sides. It is as if you have 2 entirely different equations. So like this one, I only can work with the cosine over 1 minus theta, or I can work on the 1 plus sine theta over cosine. I can't work on both of them at the same time. Like I can't multiply, cross multiply. I only can work on this, or I can only work on that. They all stay on their side. Okay? So keep that very square in your head that you aren't multiplying both sides by something. You aren't square rooting both sides. You're not doing cross multiplication or anything like that. Did you have a question?
Yeah, something would go pretty wrong if you cross multiply, correct?
This one would actually work out. The problem why we can't cross multiply, or we can't multiply both sides by 2, is a lot of these trig functions only exist on certain parts of the unit circle. A lot of them don't work with certain numbers, like they're undefined. And if you might end up proving it's true, you might end up with 1 equals 1, and it turned out it was never an identity to begin with. And one of the prime examples that we looked at, so this has nothing to do with this exact problem, but just for your sake in that question is, if I did sine squared x equals square root of 1 minus cosine squared x. We said those weren't an identity because this can't have any negative values and this one has negative values. So this would be an example of how if I square both sides, I get rid of the fact that there actually aren't an identity. And so you lose something as soon as you try to multiply both sides by a number or cross multiply or anything like that. So you have to kind of create a wall. You create a wall. That means nothing from here is going to tangle with stuff from here. Nothing from here is going to tangle with stuff from here. I'm just going to work on this side, or I'm just going to work on this side, or I might work on both of them independently. All right, so we have cosine theta over 1 minus sine theta equals 1 plus sine theta over cosine theta. I'm going to make a big deal about this really quick. See this 1 minus sine theta? Let's put a note on this side here. If you have 1 plus sine, 1 minus sine, 1 plus cosine, 1 minus cosine, so on and so forth. I'm not going to go through all the trig ones. You probably will be using the conjugate. we'll probably be using the conjugate. All right, this is going to appear over and over and over. So if you ever just see this guy sitting by itself, this 1 minus sign, it means that you can't use that Pythagorean identity, because I need 1 minus sine squared, or I need 1 plus sine squared, whatever one you're on, you need something squared. 1 minus sine theta is nothing. I can't simplify it at all. In fact, I can't really simplify cosine. I can't simplify this 1 plus sign, and I can't simplify this cosine. So without this step, you are pretty much stuck. You could break apart this into 1 over cosine, sine over cosine, but you're going to run into a whole bunch of problems doing that. So as soon as you see 1 minus just something by itself, a sine by itself, a tangent by itself, no square, you should think immediately multiply by the conjugate. And in fact, we can work on either side, but I'm going to choose this one. I'm going to multiply this one by the conjugate. And the conjugate of 1 minus sine theta is 1 plus sine theta. So I'm going to use 1 plus sine theta over 1 plus sine theta. And I'm going to multiply that by the original fraction. So cosine theta over 1 minus sine theta. All right, once I do that multiplication, we're going to see that I have 1 plus sine theta times cosine theta. I'm not going to distribute right away because our hope is something's going to cancel out. And if I have 1 plus sine theta times 1 minus sine theta, it's a difference of squares. So at this point, we should be able to just see that's 1 squared minus sine squared. If you want to show that whole step, you can. I just don't have the room for it. But we should know it's 1 squared, which is 1, minus sine squared theta. Can I rewrite 1 minus sine squared theta? It should be that one that just jumps off your page, Callie.
It's cosine squared theta.
It's cosine squared theta. So that's going to leave us with 1 plus sine theta times cosine theta all over cosine squared theta. Our cosine is going to cancel out, and we're going to be left with 1 plus sine theta over cosine theta. That's about as far as I can go. Now I'm going to look at the other side and say, oh, that's as far as I needed to go. So we're just going to do 1 plus sine theta over cosine theta. So here's my advice on these. They can get tough. All right, they can get tough. Don't look at this and in your head try to get it to look like this. All right? Don't try to visualize every single step. Do what you can. So the only thing I could do is multiply by the conjugate. I didn't know if it was going to work. I mean, I knew because I wrote out the notes and I actually did it. So I was pretty confident. But every time you start this, you don't know if that step is going to get you to the answer. What you're going to do is you're going to do a step you think you can do, follow it along the route, and don't try to force it to look like this, but just kind of follow this along and hope it comes out to this. If it becomes more and more complicated, and you run into wall after wall after wall, maybe you made a bad step to start off with. So think about, was there something else I could have did to start off with? Or was there something along the line where it was getting simpler and simpler and all of a sudden it got more and more complex? Check there. Check to see if you could have did something else there. But it won't always be just a clear road ahead. You're not going to be like, oh, if I multiply the conjugate, oh, I know the answer. All right, it won't always be that way. It might be murky, and you just got to keep walking along that path until you got it all the way simplified, and that's where you check to see if you did everything correct. All right? So follow a path, even if it seems wrong, follow it until it reaches a conclusion, and then back up. Yeah?
So would we have to use this way, or would cross multiplication be okay on a test? Or
like I said, you cannot use cross multiplication.
right.
This is a wall. This is a wall. Nothing can cross between the two. That's why I draw this wall. It's a beautiful wall too. But it's a great big wall that stops anything from going between. So I can't cross multiply. I can't multiply both sides by 2. I can't take the square root of both sides. I can't square both sides. we're treating each side independently. Okay? That's the only way to prove these are true. Alright, continuing on. We need to verify that cosecant x minus sine x over sine x equals cotangent squared x. Let's go ahead and build our wall. So that wall tells me I can't multiply both sides by sine x and hope things simplify, okay? That's what that wall tells me. I have to either work on this side or I have to work on this side. I think one is more complex than the other one, so I'm going to work on this one. I'm going to work on that side, that cosecant minus sine x all over sine x. So I'm just looking at this, and I'm looking at the cosecant. I can rewrite cosecant, right? And I guess we could do that first. Does anyone see another step we could do first, or do we want to do that cosecant first? Because it really doesn't matter. All right, let's just do the cosecant first. See where that gets us. So cosecant I can rewrite as 1 over sine x minus sine of x over sine of x. Can I rewrite anything else? Do I have any like sine squareds? 1 minus sine squareds, 1 minus cosine squareds? Yeah.
Well, you could put the 1 over sine on the lower part of the fraction, make that into negative sine x over sine squared x.
Negative sine x over cosine x? What did you say?
Over sine squared x.
Oh, okay. Oh, gotcha. Yep. It'll be 1 over sine squared x, right? Yep. What he's saying is, I can't rewrite any of this. I don't want to rewrite it all as cosecants because that's just a waste of time. It's already all in sines. So that tells me I need to break apart this fraction. All right, that's the only step I can do is break this apart. And so we're going to turn this into two separate rational expressions where we have 1 over sine of x all over sine x minus sine x over sine x. So in part, I just threw it under that guy, threw it under that guy, I broke it apart. Well, that's nice. That's just minus 1. This side is going to be 1 over sine squared x. And how that happened is A, you could think about this coming up here, or B, what I like to do in my head is that keep, change, flip. So this is just kind of a little note. Keep, change, flip would say keep the top fraction, which is 1 over sine x. Change the sign, change our division sign to multiplication, and flip sine of x. This is really sine of x over 1, right? So the reciprocal of sine of x is 1 over sine of x. So that would be times 1 over sine of x. So that's how I got that 1 over sine squared x. Make sure you know how to do that. That appears a lot. That's a very common thing to happen. All right, but now I can rewrite 1 over sine of x squared to get rid of that fraction. 1 over sine squared x is just the reciprocal of cosecant squared x minus 1. The funny thing is, this is the only time I need to know trig. This is the one and only step I actually need to know how to do trig. Because this was just, oh, and we had to do that one. Sorry, our first step did too. But basically, we split apart a fraction, we simplified those, and we came down to cosecant squared x minus 1. So this is the time where we need to use one of those Pythagorean identities. And what's that going to equal?
Cotangent squared.
Oh, isn't that what it's supposed to equal? All right, cotangent squared x, which equals cotangent squared x. We're done. We're done with that guy. So if you run out of stuff to do, break apart your fraction. If you run out of stuff to do, maybe you'll have to push your fraction together. All right, next one is 2 tangent squared x. Once again, I'm going to build that wall. Nothing can happen on Whatever happens is either going to stay on this side or it's going to stay on this side. Well, I'm looking at that. I could change cosecant to 1 over sine, but I don't think it's going to help me right off the bat. Like, that would be one step. So what can we do to those? I don't feel like changing cosecant right now. Let's just leave it as is, because I'll just have a fraction and a fraction while I'm doing it all. What can I do? What could I possibly do if I can't simplify anything using my identities? Yeah?
On the right side, you could multiply the first fraction by cosecant of x plus 1 over cosecant of x plus 1, and the second fraction by cosecant of x minus 1 over cosecant of x minus 1.
Perfect. We're going to push those two things together. We're going to push, if I can't do anything with these separated, I'm going to push them together and see what happens. And the only way to push them together is if they have a common denominator. So just like Brian said, I'm going to take this denominator and multiply it by the top and bottom of this fraction. Then I'm going to take this denominator and multiply it by the top and bottom of that fraction. So we are going to have cosecant x plus 1 over cosecant x plus 1, multiply that by that first fraction, which is 1 over cosecant x minus 1. Subtraction sign. Then we're going to take that other denominator, that cosecant x minus 1 over cosecant x minus 1, and we're going to multiply that by the other fraction, that 1 over cosecant x plus 1. All right, cool. So on the top of my left-hand side, I'm going to have cosecant x plus 1 all over, well, that's once again a difference of squares. I have something plus 1, something minus 1. So it's going to be that first thing squared, so cosecant squared x minus 1 squared, which is just 1, minus cosecant x minus 1, all over the exact same thing. This is still a difference of two squares. I got cosine x minus 1, cosine x plus 1, so it's going to become cosecant squared x minus 1. So pushing these two things together and making sure we distribute this negative sign, we are going to have cosecant x plus 1 minus cosecant x plus 1 all over cosecant squared x minus 1. My cosecants are going to cancel out because I have a positive cosecant and I have a negative cosecant. So on top, I'm just going to have 2. 1 plus 1 is 2, I'm pretty sure. Could be wrong, but I think it's right. So we're just going to have 2 on top. And now I'm going to look at, I have cosecant squared and I have a 1. Probably going to look at one of those Pythagorean identities. And can I use one of those to rewrite cosecant squared x minus 1? Callie? It'd be cotangent squared x. Well, we could rewrite this as 2 times 1 over cotangent squared x. Well, that's just 2 times tangent squared x. That's as far as I can go with this. Now I look back at what I wanted it equal. Got it. Got it without thinking about it. All right? My only goal was to push these two things together. That was my only goal. And then I just went with what happened after that. All right? So these things have a way of just sorting themselves out. All right? Unless you get to a super complicated one. Most of these, as long as you do that first step correctly, everything else kind of just tumbles down until you get to the correct answer, which is 2 tangent squared x equals 2 tangent squared x. All right, any questions on any of that? Good? All right, this guy's a little different. This guy's a little different. And it's a little different because we have to do a little work on both sides. All right, we do have to do a little work on both sides. So normally I could just pick one and just do the work. This one we're going to do work on both sides. So I build that wall. And the reason why I kind of know we have to do work on both sides is because I'd probably start with this side. I'd start with this side because 1 minus sine squared of t, what does that equal? Yeah.
Cosine squared of t.
Cosine squared of t. So I would just immediately see that, hey, I could simplify that really quickly. Cosine squared of t. And then I'm going to go to the bottom and say I don't want a negative t in here because it's going to be hard to push a negative inside of this. So I'm going to either bring it out front or I'm just going to let it disappear. What am I going to do with that negative t value? Am I going to pull it out front or is it just going to disappear? And this is on your identity sheet. JP, what's going to happen to that negative sign?
Put it in front of cosecant.
Yep.
So it'd be 1 plus cosecant t.
It'd be 1 plus cosecant t. And I'm going to tell you right now, this feels like a natural stopping point. It takes some practice that the screen knew it was a natural stopping. It's like, I'm done with that, man. To know where a natural stopping point is, but this is basically our natural stopping point. All right, we could split this apart, but we're going to see we have cosine, we got sines. So this is kind of like a natural stopping point because I simplified everything up here. So let's go ahead and look at the other side. Well, if I rewrite the other side, I could rewrite this as 1 minus sine of t. But wait, what? Wait, what? I'm going to get rid of those parentheses. They get annoying to draw every single time. I'm going to do something really quick. Why would I highlight that? Yeah.
Because something's not right.
No, everything's right.
Well, it doesn't add up to the numbers.
It will. We'll make it work. John? Oh, never mind. 3. Multiply by the conjugate. If you see 1 minus sine, 1 plus sine, 1 plus cosine, 1 minus cosine, 1 plus tangent, 1 minus tangent, 1 plus cotangent, 1 minus cotangent, 1 plus secant, 1 minus... If you see that and you can't think what to do next, that should be a warning sign that says, whoop, whoop, conjugate. That's a conjugate alert. So my advice to you is whenever you see that is give it a shot, see what happens. If I multiply the top by 1 plus sine of t, and I multiply the bottom by 1 plus sine of t, this is going to simplify down to, well, it's a difference of squares, so it's 1 squared minus sine squared t all over, and I'm going to go ahead and distribute of cosecant t plus cosecant t times sine of t. Well, if I was here, I would think, well, maybe I went too far with this one, because what did I originally have on top there? I originally had that 1 minus sine squared t, right? So what does 1 minus sine squared t equal? We already did it once, we can do it again. Callie? Cosine squared t. We already have the right thing on top. We're done on top. Our top is done. We have cosine squared t that's going to equal. So on the bottom, I already have this cosine t by itself, so I'm not going to adjust that one. I already have it by itself. I'm just going to worry about this little section here, and I'm going to rewrite the cosecant there. So I'm going to leave that as cosecant t, plus I'm going to change that cosecant to 1 over sine t times sine of t. Well, if I have 1 over sine t times sine t, what does that equal algebraically? what does it equal? 1. It just equals 1. So that means that we're going to have cosine squared t over cosecant t plus 1. But aren't these really the exact same? What's 2 plus 1? What's 1 plus... Whoa. 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 Let's just pump the brakes for a second.
I'm pretty nice now.
What's 1 plus 2?
I'm pretty nice now.
What's 1 plus 2? What's 1 plus 2?
I'm pretty
What's 2 plus 1? Doesn't matter what order. These two things are equal. We are done.
You alright there, buddy?
Jacob's.
You alright there?
Whoa. Get out of there. All right, so those two things are equal, and we're done. All right, so if anything, I did too much work on this side. All I really had to do was take out the negative side. But generally, if I do something to a side, like even pull out a negative, I just look if there's something really quick I can simplify on that side. All right, just turned out that was just a little bit too far. All right, any questions on that one? Thought I had one more, but I do not. Ugh. Done talking, I guess. All right, let's go ahead and start the homework.